Hello and welcome to lesson 1 of week 2. In this lesson, we are going to look at the Pandas library in Python. My name is Mildred. Last week, we looked at how we could create a virtual environment where we can install all our dependencies for a particular project or an app. And so you want to activate the same virtual environment because we are going to have some installations that we need to do during the course of this lesson. Now, we're talking about data science, but what is data science? In computer science, data science is this branch that deals with how we store, how we use, and how we analyze data to extract information that we might not be able to see with the naked eyes or without some advanced analysis to do that. So we want to import the Pandas package, and before you to do this, if you don't already have it, you want to pip install Pandas. So make sure your virtual environment is activated and then you run this pip install Pandas, and if you already have it, it will tell you requirements already satisfied. If not, it is going to install it, and then you go ahead and import Pandas. Conventionally, we import has, give it an alias so that instead of saying pandas dot, we'll just use pd as the name. Let's try to see the version that we have. So we'll say print, we want to print pd dot version. So we use this to see the version we have, and so when I run this, we can see, and it tells me version 2.3.3. so we know that we have Pandas installed and ready to use. We have something we call a series. Within series like this, a series is a one-dimensional array which is labeled, and it's just like we have a column with an index. So we can create a series from a list, from a dictionary type. We can create it from even a numpy array or from a scalar, and we're going to see how we do all of that. Let's say we have a list of items. Let's say we have a list of, let's say 10, 20, 30, and we have this list and we want to make it a series, and we use pandas. So let's say we call it series 1 will be equal to pandas is imported as pd, so we say pd dot, and we have series to use pd dot series. In a pair of parentheses you put your list, so this becomes a pandas series. So we can also do this from list. We can have index labels, and if you want to have labels, let's call this s2 for instance. Let's say s2 is equal to pd dot series. We'll have that, and then you have the index, and you can now put an index. Let's say we want to name this, let's say we have a b c as the index for it. All right, so when we try to print out, let's print, let's say from list s1, and let's print, let's do \n with index. Let's say from list with index and \n s2. Okay, when we run this, let's run this, and we'll have a, so this has to be quoted. Okay, a b c, so the rules still apply. An int is without quotes and a string is with quotes, and so when we run this now, we can see from list we have, it gives automatic index 0, 1, 2, and it makes it 10, 20, 30, and then when we say from list with index, we rename the index to a b c. So we can also have from dictionary. At this point, the keys will be the index. So let's say s3 is equal to pd dot series. So to create a series, you just use the series function or the method you call the series from pandas library. So we'll say pd dot series, and in a pair of parentheses, let's create a dictionary. Let's say we want to have the key of this to be apple, and let's say we have 2 apples, and then we want to have, let's say we want to have banana, and let's say this will have, let's say 5 bananas. So, and now we can print from dictionary s3 here. Let me comment this out and let me run this, and so we can see the apple is now the index, and then the frequency will be the value. From scalar, you can broadcast across the index, and when we say scalar, we mean something like, let's say I'll put s4 and I'll say pd dot series, and in a pair of parentheses I want to have, let's say I want 7, and I want to broadcast this along index. So I want to have the index to be, let's say we'll have index, or let's call this index x, index y, index z, and so it's going to broadcast this 7 across these 3 index. So we'll have x, y, z, 7, 7, 7 will be each of their values, and so let's put here s4. So let's call this from scalar. So we see x is 7, y 7, z 7. So you want to practice with this. This is just the basics of the Pandas library in Python, and this is one of the libraries that you use in data science where you work with data sets. Okay, so we want to look at the different operations we can do with pandas. We can get the sum, we can get minimum, we can get maximum. We can also do things like boolean max. We can align things like alignment on index. All of this, we're going to create more data for us to work with data, and then we'll learn how to import data from a file. As we go along, we'll learn how to get data from an API, and we'll load it maybe into a table or something. We call this table a data frame, and then we can know the kind of operations we can perform on the data to begin doing data science and migrate to machine learning and the likes. So I'm going to delete this, and we're going to work with that. Let's say we want to create a data frame. A data frame is a two-dimensional labeled and structured array, just like a table. The data frame has rows and columns, and each column is a series. Now, when we want to create a data frame, we create them from a dictionary of lists or a list of dictionaries, or from NumPy arrays. We'll look at NumPy next week, or we do that from a CSV file. So I have a CSV file here and an Excel file. So CSV is just comma separated values, and then the Excel values that we have. Let's say we want to create a data frame. We'll use pd.dataframe. Assuming we did not use as pd, we will do pandas. So like we did for series, we can do pandas.series. So it's just easy to write pd. So you alias. So we'll import pandas as pd, and then we'll call data frame. Let's call our data frame df. So we'll say df is equal to pd.dataframe, and in a pair of parentheses we create the data that we want. So we want to pass in a dictionary and create a data frame from this dictionary of items. So let's say I have a dictionary here, and I'll have this field which is a name, and I'll put the value for the name should be a list, right? So I'll put the names of people. Let's say I want to have Alice, I want to have Bob, and I want to have Charlie. Then I want to have another item here. Let's say we want to have their ages, and I'm going to put the age here 25. I'll have 32, and I'll have 37. Let's have another one. Let's say the score, and for the score here, let's say I'll have 88.5, I will have 92.0, and I want to have 97.0. Okay, so let's have all of these values, or let's say 79. Let's make it like this. Now we have these 3 names, 3 ages, 3 scores. So everything from the first index belongs to themselves, second index, third index. We want to use this data frame, and we want to look at the different methods that we can call. So we can print data frame to say print df, and we'll see like it's going to be a table of rows and values. So Charlie, sorry, this is a comma, so I'll run this, and you have name, age, score, and you can see it has the index 0, 1, 2. Now there are other methods we can call, like you want to get the first 5. Now this is just 3, so you won't see, you get everything printed out. You do df.head, so you get from index position 0 to 4. So let's add more, let it be up to 6 and see. Let's say we have Matthew, we have Luke, we have John, so we have 3 more. So let's say 32, 31, 20, and then add another score, 94.8, 87.5, or let's say 0.4, 60.6. So we've increased the values, and when we do df.head, it will print the first 5. So John is not printed because we say .head. If we say .tail, it will print the last 5. So we have the last 5. Okay, analysis is not printed. If you want to get the rows and columns, you can say the number of rows or the matrix. You can say df.shape. You can say df.shape and run, and it will print a shape 6 by 3. So you know that you have 6 items there, and you have 3 rows. It is rows and columns. So you have 6 rows and 3 columns. Okay, so df.head, tail, and shape are basic operations you do to inspect the data, which is the first thing you always want to do when you have data. So normally you're not going to get your data as just little like this. You can get thousands of records from an Excel file, from an API, from a database, and we're going to look at that. Now we want to look at the data types. You can say df.dtypes, and it will print the data types. Age is an int 64, score float 64, and name is an object. Okay, if you want to get just the name of the columns, you want to perform data analysis, or you want to perform some AI, you do columns. Okay, and when you do df.columns and you run, you see the columns name, age, and score are the columns that you have on it. If you want to get a concise summary of the data frame, you can say df.info, right? And then when you run this, you get the summary here, name, age, score, and the summary we'll get here is that the info of name, age, score. You get this, like everything printed out here. If you want to get the statistics for numeric columns, for instance, you can say df.describe, all right? And now it will give you statistics for the numeric column. So for instance here, you have, I'll put a pair of parentheses, and so now you have age, you can see the statistics, the number of people, 6, the mean, you get the mean age and the mean score, the mean, so it only gives you for numeric columns, and this is how you get statistics. So if you are writing a test and they ask you to give you the mean of the ages of the score, this is what you will use. Like this, you use describe, right? So you can select the columns and rows like this. I want to print just the name, so I can say df, just as you do for a dictionary, a square bracket, and then age, the column name, and then we can see the ages like this, right? If you want to do that for any other one, you can do that. You'll see something like df.age, but these are not safe ways of writing. You have unexpected outputs, but now it works fine, but it is less safe to do that. You can have multiple columns, like if I say df dot, I want to get the name and the score, so I'll put this pair of square brackets and another square bracket in it, double square brackets to get it, and then I'll put the name and the score that I want, right? And then when I run this, I'll print the name and the score out. If you want to find the row by the label, you can use df.loc. when you do .loc like this, so df.loc, and then you put in the row label, and let's say we want to do, let's say df.loc 0, and then when we run this, we have Alice is 25 and is 88, so this is just for the row df.loc. If you want to get the position by position, you can use ilog, and so you put the row position. If you put df.ilog 0, and then we'll still get the same thing if it's by row position like that. So as we go deeper, we'll see the difference between loc and ilog, but this is where we end this lesson. In the next lesson, we'll see how we can import from a CSV and Excel and also a JSON file, and how we can work with these data. Thank you, and see you in the next lesson.